I am Dr. Anantaya MB, Professor and Head of Civil Engineering Department, Sai Vidya Institute of Technology, Bangalore. Today we will see one more problem on rolling UDL lesser than span of the beam. It is of Module 2 of ADS subject. See, a UDL 5 kN per meter and 5 meter long moves across a beam of 15 meter long simply supported at the ends. Determine bending moment and shear force at a section 6 meter from the left support. Also calculate absolute maximum bending moment, absolute maximum shear force. See, this is the problem given. Span of the beam is 15 meter. The section given C is at a distance of 6 meter from left support. Length of the UDL is 5 meter. Intensity is 5 kN per meter. Now we will calculate maximum shear force at 6 meter from left support here. So for getting maximum shear force, we have to keep the UDL left of C. 5 meter means totally 6 meter. The UDL comes inside. Therefore, then we draw the ILD for shear force. This is the ILD for shear force at section C. Here this coordinate is x by L. This is L minus x by L. L means 15 meter. X means 6 meter. Therefore, it comes 0.6 meter. This comes 0.4 meter. Since it is UDL, we have to consider the area of this diagram into intensity for getting the negative shear force. So Y1 we have to calculate from the similar triangle property. We can calculate Y1. 0.4 divided by 6 equal to Y1 divided by 1. From this one Y1 I got 0.06. Now negative shear force is area. Y1 plus 0.42 by 2 means average height I am getting. Into length it will give the area of this diagram. Into intensity it will give you the force. Therefore negative shear force at 6 meter from left support equals 0.06. Y1 is 0.06 plus 0.4 by 2 into length of this is 5 meter here. Remaining is 1 meter, 5 meter into intensity is 5. I am getting 5.27 kilonewton. Now we will calculate the positive shear force. Now we will calculate the positive shear force. See, for positive shear force we have to keep the UDL to the right of the section line, 5 meter length. Then the ILD for shear force is like this. It is drawn at the peak is at the point C. Here L minus x by L, this coordinate. This coordinate is x by L. X is 6 meter, L is 15 meter. Now, since this is UDL, we have to consider the full area of this, full area. Therefore, we want to calculate this coordinate from the similar triangle property. 0.6 divided by this 9 equal to Y2 divided by this length 4 meter. From this we can calculate Y2. Then average area is 0.6 plus 0.26 by 2 is average height into length is 5 meter into intensity 5. We can get the shear negative positive shear force. So it is 0.6 plus 0.26 by 2 into 5 meter is the length into intensity 5 meter. It is 10.75 kilonewton. Now we will calculate maximum bending moment at 6 meter from maximum bending moment at 6 meter from left support. 6 meter from left support. See here, this is the maximum bending moment at 6 meter. See here, this is 6 meter, remaining is 9 meter. The ratio of this beam splitting is 6 divided by 9. I written here 6 divided by 9. 6 divided by 9. In the same ratio, I have to divide this UDL also, which is of 5 meter length. For that case, I am taking x and 5 minus x. The ratio is same. From here to here, I am taking x. Total is length L. Therefore, 5 minus x is this length. Therefore, x divided by 5 minus x. X divided by 5 minus x equal to 6 by 9. 6 by 9. From this I am getting this. What is this x length? It is the 2 meter. Now I got this x equal to 2 meter. Therefore, what is the point? This point and this point should coincide. That means from the section point given, this side the UDL is 2 meter. Right side is 3 meter. Total is 5 meter. No, x means 2 meter. 5 minus x is again 3 meter. Therefore, we have to keep the UDL such that to the left it is 2 meter, to the right it is 3 meter. Then we will calculate we will draw the ILD for bending moment at section C. This is the ILD for bending moment at section C. Therefore, P coordinate is L minus x by L into x. X is 50, L is 15 meter, x is 6 meter by L into 6. It comes 3.6, this coordinate. Now, the UDL is there. So we have to calculate this full area of this. Therefore, I have to calculate this ordinate. For this ordinate calculation, I am considering this triangle. 3.6 divided by this 6 equal to y3 divided by 4. From this I got y3 equal to 2.4. Similarly y4 I have to consider this right triangle. 3.6 divided by this length 9 equal to y4 divided by 6. From this I got this also 2.4. Now for calculation of the load I am taking this area once plus this area. That means y3 plus 3.6 by 2. y3 is 2.4 plus 3.6 by 2 into 2 meter length into 2 into intensity is 5 kilonewton per meter plus 3.6 plus y4, it is 2.4 only, 3.6 plus 2.4 by 2 into average height into length is 3 meter into intensity is 5 kilonewton per meter. I got 75 kilonewton meter. Now I have to calculate absolute maximum bending moment when the UDL is lesser than the span. Absolute maximum bending moment. See here, for absolute maximum bending moment, the UDL, the center of the UDL and center of the beam we have to coincide. See, the section is maximum bending moment is at the center. Therefore, the length of the span is 15 meter. The center of the beam is 7.5 meter. Therefore, x equal to 7.5 because section is came to the center. Again, center of the UDL should coincide here. Total is 5 meter means 2.5 this side, 2.5 meter this side. Then we will calculate the bending moment. That itself is the maximum, absolute maximum. Therefore, this is the ILD for bending moment. See, P coordinate below center is L minus x by L into x. Here L is 15 meter only. X is 7.5 meter by 15 into 7.5. 3.75. This coordinate I got 3.75. So, this is the UDL. Therefore, we have to consider this full area. So this coordinate how to calculate? From this similar triangle property we can calculate 3.75 divided by this equal to y5 divided by this y5 I got, y similarly I got y6 also. Now the area of this area plus this area into intensity I am doing. Therefore absolute maximum bending moment equals y5 plus 3.75 by 2 into 2.5. See here 2.5 plus 3.75 by 2 into 2.5 into intensity 5 plus right area 3.75 plus y6 is 2.5. 3.75 plus 2.5 by 2 into 2.5 length is 2.5. This length is 2.5 into intensity is 5. We got 78.16 kilonewton. Now we have to calculate absolute maximum shear force. Absolute maximum shear force. Here absolute maximum shear force is nothing but maximum value from reaction VA and VB. First we will calculate reaction VA. So for reaction VA we have to keep the UDL near the point A for getting maximum shear force at A. This is the ILD for shear reaction. Then we have to calculate, since this is the UDL, we have to consider the area of the ILD. This y7 coordinate I have to calculate 1 divided by 15 equal to y7 divided by 10. From this I got 0.66. Therefore reaction is this height plus this height by 2, average height got into length into intensity. So it is 1 plus 0.66 by 2 into 5 length into intensity 5. I got 20.83 kilonewton. Similarly, I have to calculate the reaction VB. See, for reaction VB, I have to keep the UDL near B. Again, same way, this is the ILD for IA, this ordinate reaction. This is the ordinate 1 here. I have to calculate this y8. It is 1 divided by this length equal to y8 divided by 10. It is also I got 0.66. The area is this plus this by 2. Average height I got into length. It is the area of this ILD into intensity. It will give you the load. Therefore 0.66 plus 1 by 2 into 5 into 5, 20.83. Both reactions are same. Therefore absolute maximum shear force is 20.83 kilonewton.